Right, so welcome to this second part on precedency graph and their use in conflict serializability. So the first thing was, in the last video, or in the, say, first part of the video, we saw how to construct a precedency graph. Now, and of course we have done so with an example. Now let's see why on earth we need these precedency graph. Like, okay, I mean, they're good looking, but why do we need them? Well, simply, it's the topic for this part, which is to test conflict serializability. So we say to test, if a schedule is, well, let's call it S, is conflict serializable, yeah, we have to do two things. Let's see what these two are. Number one, construct the precedence graph for S. So construct precedence graph. Let's even make it capitalized for S, yeah, which is something we have already learned. Now we need to do a little bit more, which is if we say if the precedence graph, yeah, has circles, or let's say, well, let's put it the other way around, is no cycle. Let's call it, if the precedence graph is no cycle, which means has no cycle, yeah, which means doesn't actually go around itself, yeah, then what do we say? S, yeah, is conflict serializable. And then S is conflict serializable. And of course we say otherwise it's not, just, you know, to make it clear. Otherwise it's not. Which means if it has a circle, it's not. It is not conflict serializable. Okay. Wow. Okay, so let's have example one. And let's have some, you know, schedule. Let's have it as R1 read X. Then let's have W1 on X. And also let's have R2 on X. I'm aiming to have two transactions only, yeah. W2 on X, then R1 on X, and then W1 on X, and let's also have okay, R1 on X, W1 on X. R1. You know what? Sorry, I just need to change this to Y. I don't know why I'm having all of them reading on X. Okay, so this is Y, and then read 2 on Y. Yeah, just to make it, you know, easy to understand, we have it like this. We start reading and writing on X, then we end with reading and writing with Y, as you probably see. So we are reading and writing on 4 elements on Y and 4 elements on X, yeah, just to make it easy to understand. Okay, so the precedency graph for this is precedence graph. Okay, we can construct it together, but this time I will do it really quickly. Well, not really, considerably quickly, because we have done this already in a previous video. But this would look something like this. Let's see. Really, okay. Of course, we discard. We start with this. Okay, we discard this, we look at this. Well, first of all, we draw T1 and T2. So I just should have done this before. Okay, so this is T1 and this is T2. Yeah, almost. Okay, so yeah, so T1 and T2, right? So precedence graph for S. Okay, so let's go back to comparison. Okay, so we have compared this, and then W2 on X, T2. Yeah, this looks fine. Yeah, well, this kind of not looks fine. We say it holds. So yeah, and then we draw the good arrow, and let's see if we have more arrows. This is not. This is not. Yeah, and so since we are done with this, let's just actually give it a circle, just a way of, so we don't look at it. Now W1 on X, this is what we are comparing. W1 on X, okay. We don't care about this. We don't care. Well, we do care about this. Yeah, but of course it's already there. I'm not going to write there because I have done this in the previous video. So it's with the right, of course, not any of these because the elements here are Y. So then we say, okay, thank you, baby. Then we go to the read on X, yeah, which is this. Okay, read on X, read to, of course, on X, write to on X. This is no, this one is no because it is the same transaction. These are all no, yeah. So then what we say is thank you, baby. And then we go to this baby, and of course we say thank you straight away because all of the operations that come right next to it are on Y, and this is not something we are interested in, which means there is no conflicting here. Yeah, so let's also say thank you, baby. Of course, the reason I'm drawing these circles around the operations is just to say we have actually traversed them. It's your choice how you do it, but okay. We then say, okay, this baby, okay, this thing, graph, has no cycle. Which implies, what does this imply? Then this implies, therefore, let's say, therefore, S is conflict serializable. Is conflict serializable. Serializable. Okay, right, let's have example 2, guys. So now example 2, well, let's give this 1, and then we say this is example 2. Let's have some decent space. Example 2. Right, so what do we have here? I guess we will have a different set of operations, which means apparently a different schedule because we will need to show something else. So we say S. Let's see, what do we have here? We have read to on X. Then what do we have? We have write 1 on X. Then we have, oh my god, why am I, okay, sorry, this is Y, yeah, okay. Write 1 on, okay, then we have W2 on X. Then we have write 2 on Y. I mean, read to on Y, and then we have, I should just say R and W just to make our life easier. R3 on X, and then we will have W1 on Y. Then we will have W3. We have 3 things here, yeah, which means like 3 nodes. Then we have W2 on Y, yeah. Okay, so let's have a look at this schedule. First of all, what do we need to do is, we need 3 nodes. This is T1. Let's call this T1. and let's have T2, not T2, T2, and let's also have T3, yeah. And of course, we start the probably boring thing, boring comparison. Okay, R2 on X, let's see. Of course, we discard this, we discard this, we discard this, we look at this, and there is a conflict. Yeah. So we say, okay, babies, you have a conflict. Yeah. Of course, we are doing this and this. So this is from 2 to 3. Then we bring an arrow, and we say this is from 2 to 3. We have a conflict. Conflict. Yeah. Okay. Then we discard this. We discard this. We have this. Oh, sorry. I meant we discard this and we consider this. I'm sorry. Yeah, because of course, why this? Because they are both read operations, so of course we discard this. And then finally we discard this because this is the same operation and there are different elements. Sorry, the same transaction, which is transaction 2, and they are reading different elements. Okay, now we, of course, what we do is we circle this because we are done with it. Then we go to R1 on Y, which is this, yeah. So what do we do with this thing? We compare it again. Remember the predicates that we are actually comparing everything right after it, not before it. So we satisfy the condition of precedence graph construction. Okay, so of course we discard this. We discard this. We discard this. Well, we discard. Let's see. Do we discard this? Yes. We discard this, yes. We discard this, no. So the last one we consider, okay, let's actually be consistent and let's rub out these dots so we don't confuse ourselves. And then we say, okay, this is from R1 to W2. We are reading the same element and there is a read and write operation. So there is a conflict from R1, from transaction 1 to transaction 2. So we draw this conflict, yeah. From transaction 1 to transaction 2, and we call it a day. We say bye-bye. Then we go to the next thing, which is this, W2 on X. W2 on X, we start comparing. Of course, we discard this. We are reading on X, so we don't discard this. So this is from R2 to, from transaction 2 to transaction 3. We already have an arrow there, so we discard this. And then we go to W1 Y, we discard it, it's written on Y. Then we see from 2 to 3, also we already have an arrow there. Now from 2 to 2, and it's written on Y, we discard this, yeah. So we call we call this a day, yeah. Say bye-bye. And then we go to R2 on Y. Of course, R2 on Y, what do we say is, okay, we discard this, we discard this. No, we don't discard this. So from 2 to 1, actually, there is something. So let's see, from R2 reading on Y to write 1 reading on Y. Then we have something here. Okay, guess why we can stop now? Of course, we don't have to carry on with the comparison, but I will quickly carry on with the comparison in a second. So why do we stop now? Stop! Let's say stop! There is a cycle. There is a cycle. Then what do we say? This we say is how, just stay consistent. We say has a cycle, yeah. Therefore what is not conflict serializable. Is not conflict serializable. Conflict serializable. Of course, if you are answering this question, or if you come across a problem like this, you could stop here and you will be fine. Why? Because you have actually identified this schedule as non-conflict serializable, which is the objective of what we are doing. But for the fun of it, let's keep actually traversing all the operations. Yeah. So we were actually where we were. We were doing R2 on Y, and we've done it with W1 on Y. Yeah. So these two, and then we go. These are we discard this and we discard this. So we say okay, you, thank you. We are done with you. Now we go to R3. Okay, so we are here. It's just about these dots. R3 on X. We compare with the elements that come next to it, i.e. after it. We are reading on X, so we discard this. We discard this, and we discard this. So we say, okay, well, this is not a very good cycle. Neither is this. So we kind of borrow a cycle. Okay, we go to W1 on Y. Of course, what we do is we simply, discard this, and W2 on Y. Well, do we have from 1 to 2? Yes, we already have from 1 to 2, so we discard it. We are here now. We are comparing this, but we have from 1 to 2, yeah. So then again, we call it a day. Then we go to W3 and we compare it with, of course, these are compared already because, there's no conflict. They're reading different elements. So say, okay, just for the fun of it, let's just have them all cycled, which means all traversed, yeah. Okay, but of course we stopped traversing here. Just let's say stopped here. Why? Found cycle. Yeah, just kind of a flag. Okay, so this is it, guys. I hope this is well explained and detailed. I don't think we can go in more details because this is the finest details I could come up with so far. Well, of course, no, there are more details to it, but again, we have already done the part on how to construct the precedence graph. So if you are still in doubt on how to construct the precedence graph, please see that part. Okay, have a good